see you. Yeah, it's good. Great to see you all. Thanks for coming along this evening. We're very lucky we got Ian, G3ROO, who's going to talk about his marvelous antenna. I hope those of you saw his article in the recent Radcom RSGB magazine. That was really interesting, Ian. So that was good. That was a surprise to see that when I opened up Radcom. So it was good. So with Jonathan's support, Jonathan, it's over to you, Ian, and please start.
Right, well, good evening, everyone, and yes, thanks to Jonathan, we've got a little show to give you tonight. He's done absolute wonders, far better than could possibly have been with me doing it. Anyway, for those that don't know me, my name's Ian Keyser. I've got several call signs: G3ROO, G0ROO, which is the Dover Construction Club, which is still running, but only just, and GB2SPY, which is my spy radio magazine, museum. There we go, making mistakes already. Brief outline, I'm 78 years old and been throwing knives up into trees since the age of 8, when I built my first super regen receiver. That used an EBC 33 valve. You know those funny things that glowed in the dark? Anyway, I am now starting to feel my age a bit, along with a few others around me.
Yeah, thanks, mate.
And one of them is that I have trouble finding the word I want. So if I come out with a few malaprops, please just have a little chuckle. Aerials, I'm not a guru. I have been doing it so long, I know my way around them. I know how to get what I think is the best out of them. And it's been a learning curve right the way through, and I'm still learning. A big advantage that's come along has been, in fact, the aerial designing programs, such as ESNEC or EasyNEC, as it's supposed to be called. I've been using that now for about 15 years, and I'm still trying to learn how to do various things. I still have trouble with putting feeders in, but I do actually manage. In fact, I saw Peter's joined us. In fact, Peter and I, 3 years ago now, I suppose it was, Peter, we decided to make a 30 meter 2-element Yagi. And I designed it all on ESNEC, including the coils, loading coils themselves. And when it was put together, it was so close, it was unbelievable. Whereas it predicted 1.35 to 1 VSWR, I had 1.4. I was 100 kilohertz off the design frequency, and the front to back was very close to the predicted 20 dB. So it just shows you what you can, in fact, do with a program type ESNEC. When thinking about aerials, there's only one thing you can actually rely on when you first look at an aerial, and that is that at the ends of the aerial, you must have voltage. There's nowhere for current to flow, so therefore it's all voltage. And every quarter wave down the aerial, it will revert, or not, what's revert? Not revert. Invert to the opposite, where we have a low impedance, we have all current and a very little voltage. And then another quarter wave along, it's back to the voltage peak. So you can always look at the area, you can work out its length, work out the wavelength, and get a pretty good idea at the feed point of what the impedance is likely to be. The other misconception that we have to guard against is that we can't tune an aerial without altering its structure. By putting an ATU, aerial tuning unit, at the feeder end of where it joins the aerial, all that you're doing is satisfying the coax. The aerial will still do exactly the same. You might just increase the gain of the system slightly, because you've improved the match to the system, but the aerial still remains exactly the same. It still does exactly the same job. First, we have to decide what we want from aerial system. Are we interested in DX? Are we interested in working just locals, or perhaps into Europe? And of course, perhaps it's all of those things. When I'm asked what aerial should I get, I immediately say, don't get, make, build it. There's a lot of junk out there that's on the market, and I can safely say junk. And they claim that it will work on all bands. They claim that it's got these fantastic gains. No aerial has fantastic gain. If you can get 5 dB gain out of a 2-element Yagi, you've done exceedingly well. By increasing the length of the wire, you can increase the gain of the aerial. Providing you can match it, you may get a few dB gain. So these gains have got to be taken not with a pinch of salt, with a great big spoonful of it. That person that's just asked this question has no doubt gone out and spent a lot of money on a rig, £1,000, and then he goes and shoves a bit of coax on the output, pushes the tune button, and expects that the aerial to do wonders. And it will not do so. It will only do what it can do with what it's supplied. So if we have a coax cable and the output from the rig is 50 ohms and the coax is matched to 50 ohms, the energy will pass down the feeder to the far end. If that far end is at 50 ohms, the energy will be absorbed and radiated by the aerial. When you put the tuner on top of the set and push the button, you're only just sort of tuning or matching that bit of cable between the tuner and the transceiver. After that, you've got a chunk of coax, could be anything up to sort of 50, 60 foot long, at 100 puff per foot, all shunting all that lovely RF energy down to deck. And in fact, Andy knows a chap some years ago, used to be a member of the club. He had about 100 foot of coax, and wondered why he couldn't even get across town. He had, I think, Andy, he had, if I remember correctly, he had 130 foot of wire on the end of the coax. So he thought it would work. But of course, it was all being shunted in warming up the coax. So you have to be very, very careful. The proper place for any external ASMU, aerial system matching unit, is at the far end of the coax and at the start of the antenna. Now back to that question, what aerial should I build? For the beginner to the hobby, I would suggest a modified G3ROO in an inverted configuration and an AH4 balun, AH4 ASMU and a balun at the base of the antenna support. So in what we've got if we look at the screen, we see we've got 34 feet of balance, 300 ohm balance line. That, if we use the spider beam pole, as G4WIF has used, the feeder could be fed down the center of the pole to the matching unit, and then the two elements off to one side and the other. Have we got Tony's next? Tony's aerial? Can't remember what was next. Just go on to the next stage.
No, we go into the diagrams now.
Okay, no, okay, go back. We'll go back to Tony's in a minute. So basically the G3ROO, it's not really very much good on 80 meters. It's just too short, but it does work on 80. 40 meters, it works very well indeed. And providing it's matched at the bottom of the feeder properly, it can work on most of the other HF bands. So that's why I say having the AH4 at the bottom of the feeder and then the matching there, then the feed the coax back to the shack, 50 ohm coax in this instance, not the original G5RV, and we satisfy the coax. Now we want to satisfy the coax because if there is a VSWR on the coax, it not only has transmission problems, it's not working as well as it should. It will also be acting as an aerial and picking up any noise if the coax is passing through a noisy environment on its way back to the shack. So that's one thing we definitely don't want. The AH4 matching unit will satisfy that and make the cable work really properly. While I'm on here, the G5RV shows two nice insulators at the end of the wire. In fact, you've got to remember that at the end of the wire, the impedance is very, very high indeed, and the voltages are very, very high indeed. And any loss due to conduction across the insulator due to moisture and soots and things like this are going to reduce the voltage, which in effect is a waste of energy and reducing the radiated signal. So I would say at least two insulators joining. That's a fun to think about. That's one picture we haven't got of showing the two insulators joined together. Anyway, we digress. We digress. Now, the next picture you're going to see is in fact the polar diagram of the G5RV antenna on what band did we put it on? Was it 80?
80.
It was on 80, and this is what we expect. Please ignore the figures down in the bottom right hand corner because there is a slight error there which we can't correct at the moment. But basically you'll see it's like a lozenge. I call it a lozenge, a jelly sitting on the table. And most of the signal is being radiated vertically. And as we come down to 30 degrees, we've already lost 5 dB. When we get down to 20 dB, we've lost 10 dB of signal. Not to be sneezed at. That's 2 S points we've lost just on the DX beam heading or elevation that we're interested in. If we now go up to the 20 meter polar diagram of the doublet, we see something more interesting happening and why it works quite well on 20 meters. Can we
do the Marconi T next?
Yes, okay. Now, if we now look at the next one, which is the Marconi T, this is feeding the G5RV, not as through a balun, but by joining the bottom of the feeders together, so they're one wire, and feeding it via the AH4 against ground. Now you can see the maximum radiation is about 30, 33 degrees, 35 degrees. That's the green blob. And even at 10 degrees, it's only 5 dB down, considerably better than on the doublet version, on the standard G5RV. But the really interesting thing is the vertical. There's no pickup for 20 degrees either side, virtually no pickup up there at the top. So that means that the strong stations, signals coming in from, say, Europe and GB, for high angle signals, are not going to be causing so much interference as they would be if you were in the doublet mode. The doublet is a dipole mode for the uninitiated.
So what about the G4KJS doublet?
The G4KJS doublet is in fact a considerably bigger area. It's the same as mine. It's an 80 meter dipole, so that's 40 meters across the top, and it's about 50 foot high. Sorry, what's 50 foot? Anyway, 50 foot. I think everyone knows what 50 foot is. So it's on a quite high pole. We now see that in fact the maximum radiation in the doublet form is really vertical, and the low angle radiation is in fact worse than the G5RV. but the gain figures, in fact, will be slightly bigger. So we get an increase in gain on the doublet mode. Do we have next on the thing?
The 20 meter G4 KJS doublet.
Okay, 20 meter G4 KJS. Okay, is it? So this is now when we go up to 20 meters using the big aerial. This is at Clipgate Fire Airfield up near Barham. And we see some rather interesting low angle lobes. They are 10 dB down on the main lobe, but there is one big plus to this aerial when you look at it now, because we're now going to look at it from the top down in 3D. So this is the 3D polar diagram. You can see we've got 4 nice major lobes: northwest, northeast, southeast, and southwest. And the funny squiggly lines are just because they are showing it in 3D. It's like a contour lines. That's the word we want. They're contour lines. If we had, he's polishing his nails.
They can see. They can see.
They can.
Yeah,
they can. Yes. In the ESNEC program, we could swing it round, but we couldn't accomplish that online. It would have been very difficult to try and do it online. So now what we're going to do is actually superimpose that on a great circle map of the world. And if you look at that great circle map, you'll see the continents are quite nicely separated in direction of 90 degrees to each other: northeast, southeast, southwest, and northwest. So now if we superimpose the two together,
as if by magic,
this is if by magic. There, look at that. The actual aerial is now putting lobes over those continents just right. Absolutely beautiful fit, unless you want to work Cape Town.
Or India.
Or India, yes. India's a little bit left out in the cold. But yeah, what was I going to say? I've lost what I'm going to say. But it's oh yes, that's right. To get this pattern to do just this nice pattern over the world, we actually need the aerial orientated east-west. So when you put an aerial up, you actually want to try and think about how any polar diagram can be used to enhance your signals over the major continents.
So can I ask a question?
Yeah, of course.
So what about the effect of the antenna being at different heights?
It varies the shape of those contours.
Oh, okay.
So in other words, you can in fact say you could vary the height. In my case, I could in fact vary. Oh no, not now, I can't. But vary the height of the antenna to actually improve the signal strength. You can get 2 or 3 gain increase in gain, dB in gain, if you get the heights right. And in fact, we did some experiments, many years ago now, with a 3-element Yagi on 20 meters to Japan. We found the ideal height usually was about 35 to 40 feet. That's when I had a 100-foot tower and I could raise it from the shack. We were just sort of messing around. It was quite interesting to see how the signal was changed.
Is that anything to do with the reflected wave that comes off the ground?
Yes.
Being in phase with the main
wave,
right,
giving your angle of radiation, changing the angle of radiation. Right. Yes.
That's interesting.
The optimum angle. But it's not vast, but it's there. We can tell the difference. Yeah.
So,
right, what's our next one? Now, the next most important thing about any aerial system, I should say, is the grounding. All that aerial current that flows up the aerial from your transmitter has to get back to the body of the transmitter. And the only way it can actually do this is, in fact, by inducing currents within the ground to flow back to the, as you pointed out, it's a low impedance ground, back to the transceiver. If it's got a resistive element, all it's going to do is to heat the ground up and waste the energy. So earthing is extremely important. A single ground rod at the base of the aerial is of course, the absolute bare minimum, but it is really is extremely poor. I have got massive radio systems out, which I've been putting out over the last 50 years. And one of them, which is well over a mile long, and it's got hundreds of earth rods down it. And it was this aerial that in fact enabled me to get my first ZL on contact on top band. And because it was on the long path down to the southwest. And I could tell when it was raining because my VSWR altered as it rained, as the ground improved, the VSWR improved. And the morning I actually worked for ZL was in fact, it'd been raining all night. And I always put it down as being the major point. But I had not paid attention. I had not really thought of the attention I had to pay directly beneath the aerial. Of course, the greatest field is directly beneath the aerial. So therefore, that's where you really need the best possible earth. We could put an earth mat down, as the broadcast chaps do, so that there is a good return back to the transmitter. But apart from putting chicken wire down, which is quite difficult to do, it's not too difficult, but it's a lot of work and to be avoided if at all possible. But use of radials, and they don't have to be resonant radials, any length of wire underneath the aerial, in effect, shorts out that bit of ground. And if they are actually got earth rods down those radials, that in fact improves the actual shorting out effect. Of course, you can't, the XYL more than likely object if you did put a chicken wire down over the whole lawn, although it soon disappears. Think of the poor chap that has to go and dig it up when he wants to put a vegetable garden or a flower bed, because it's the most terrible thing to try and get out of the ground. So I always say that the best is a ring around the perimeter of your land on the fence lines, and then earthing that down at regular points. Andy's done this, and he got some very good earth resistance return figures.
What about if you had a metal roof? Could
I
you
have
do something with that? Oh, have you?
I have.
Oh.
I hadn't realised the importance of this. This is about 10 years ago now, and I suddenly realised that my main aerial dropped down vertically into my workshop where the all the matching circuit was, and then it was a coax run back to the main shack. And there was me under my aerial. I had a 15 meter by 15 meter steel workshop roof. So I got the angle grinder out, and all along the edges, I cut little tabs and wound copper wire around and right the way around to bond all the sheets together back to my aerial matching unit. And then I also put earth rods around the place and vertical wires down into earth rods into the ground to make as good as earth as possible. And this just improved my signal to the point where one American said I was like a beacon on top band. They came, I always used the same frequency, and they always used to check to see if the beacon was on the air, and that was me.
That's the compliment, isn't it?
And it did pay off, and that was about 7-8 years ago now. And since then, I've now got 280 plus countries on top band, which is a fairly impressive figure. Of course, they're very difficult to find from now on. But the wire around the perimeter with earth rods is very good. Now, earth rods, another pet hate. These lovely earth rods that you pay, I don't know, 5, 6, 7, 8 pounds for, nice copper looking earth rods, but they're not. They're in fact steel shafts with copper plating, And if you extract one out of the ground after a few years, you just come out with a rusty rod. However, in the picture there, you'll see 22mm copper pipe, which you can buy new, or you can do as I did. I went down to the local scrap yards and went through their piles of copper pipe. Didn't matter if they got joints in it. Any straight bits I bought at scrap rates, not the scrap rate they pay you when you take it in, considerably more, but it doesn't really matter. It's still fairly cheap way of doing it. Solder a wire around the top to go up onto your ring wire, welt them into the ground. There are various ways of doing this. You can either have it, knock them in with a sledgehammer, or as I've done, I've made a little union that goes into my SDS drill, and I use the SDS drill on hammer action, and it goes in neatly into the top of the pipe and drifts it into the ground.
Do you know what I've done previously? I've used 15mm. No, I've bashed the end of it flat with a hammer, and you get a kind of like a knife
effect, right? Yes,
and
it does go down. Yeah. 22mm just goes in. It doesn't. Right. You can welt it with a sledgehammer, right? And it sometimes buckles if it's a big flint. Mm. But the yeah, no, I think we covered it. Okay. We covered earth rods. Yes, we covered earth rods. Now, that's just a picture of my workshop roof. You can see it's one long workshop roof on the right-hand side. Then there's another one that's another layer. And then there's the twin wall. Well, over that twin wall, there are copper wires running over to the museum, which you can just see on the left-hand side there. There's the museum roof. And these wires come across the top of the thing. You can't see them. I think that you just can't see them. It's too dark. But that so that makes a complete grid on them. On the right-hand side, you see the long roof. You can just can you see? No, you can't see the solar panels, can you? No. I've got a solar panels. Yeah, there are the solar panels. No, that's not. That's the side of the workshop. You can't see this. There are the solar panels. Look, down here.
I don't know if you guys can see where my cursor is.
Bottom left-hand corner.
Yeah. No, we can't see. We can't see it, Jonathan.
Sorry.
And we can't see where Ian's pointing either.
Bottom left-hand
bottom left. We can see the solar panels are at an
frame. Now, do not worry about solar panels causing noise. They do not cause noise in their own right. That panel is giving me 240 volts at 10 amps in broad sunlight, and I use that for water heating, and it does a superb job. My main solar panel bank is in fact 16 panels, the usual 16 panels. Now that has got an inverter on it. I can detect some panel noise, but it's very, very slight. And if it was causing any problem, I could go and easily turn the inverter off and just go on the air. But it is so slight. It tends to be like any switch mode power supply noise. It's a little burble, or it's a burble. But I would say it's between S1 and S2, and they're on discrete frequencies, so you can avoid them with a bit of luck. The picture on the right, where you can look to see the caravans, there's a black pole. Now that is a spider beam pole lashed to a piece of timber, which was screwed onto the side of the workshop 9-10 years ago. And that is a 40-meter vertical antenna, which I used to keep a sked with my friend down in New Zealand on a daily basis. And very rarely did we actually not manage to have our sked.
This is it here.
And you can see it on the top left-hand corner. You can see the sticking up. There's no guying on that 12-meter spider beam pole. And if anyone that knows Whitfield knows, it's a very, very windy location. And there's been no problems with it whatsoever. Nothing's ever been done to it, and it's still secure. That's using terylene twine to bind it to the post. the picture on the left is in fact the main tower that holds up the Marconi, the Marconi stroke doublet 80-meter system. And the next rod you can see alongside it just to the right, oh, you can see a feeder coming down, then you can see a rod sticking up in the air. Now that is the 18-meter spider beam pole holding up the center of the aerial system. And then at the far end, you can see a tower with a scaffold pole slightly bent over at the top, which is in fact the other end of the 80-meter dipole. On the right-hand side is the base of the spider beam pole, which comes through the workshop roof and is waterproofed, or almost waterproof. You can see the slight leakage. And coming out of the bottom of it is the 450 ohm twin feeder, and into the matching unit, which is where the toroid is and the relays. And then that is being driven by a Pulsar ASMU. And that I can switch between horizontal and vertical polarization to give the multi-band effect. By the way, we've left that aerial off the program, but to give you some idea of the versatility, on 160 meters, it's only usable on vertical polarization due to not being able to get a match on 160 meter as a doublet. Not that it will be much good. On 80 meters, it works beautifully as a doublet, really is a good DX antenna, as you might expect being so high above ground. That's 65 feet above ground, the center, and 75 feet at either end. On 40 meters, it can work on vertical or horizontal polarization, giving either DX capability or EU capability, if you think of it that way. There's not vast difference. It's only 10 to 15 dB, 2 to 3 S points difference, but the difference is there, and it makes all the difference if you're trying to bust the pile up. I can't remember off the top of my head. There are 3 other bands, well, modes I cannot do, but I can always use it on either the Marconi or the doublet mode on all the HF amateur bands. So it's a complete aerial system. So much so, I've taken the beam off the top of the tower, I've taken the rotator out, and no longer do I have an HF beam. I'm more than happy with the performance of the aerial, but it's an unusual aerial. It is. I'm very fortunate to be able to have that. Can we go back to Tony, G3ROO? Is that the next one?
It's the next one, yeah.
Oh, good. Okay.
Ready?
Yeah, go ahead.
Okay.
Right now, Tony lives down by the River Severn, not too far from Chepstow. I can't think of the name of the town. He's going to be giggling at that because he's almost certainly listening. Now, we put this up a month ago now, I suppose it must be. You can see the spider beam pole. That is the 12-meter pole with 2 sections out the top. So it's about 30 feet. And you can see we've enhanced the 2 wires of the G5RV coming down to the fence at either end of the boundary. And you can also see just some stabilizing white guys on the spider beam pole. Thin twine, thin terylene twine, just come back to stop the thing wobbling and in the winds. Now, we put that up, and he was using it just in the vertical mode because the relay box hadn't been completed. In fact, it still hasn't been completed, but I reminded him about that yesterday on the phone. But in the Marconi mode, he's worked across the States on 80 meters. First time ever he's managed to do that. So you can see that the G5RV, if fed properly, can do a lot more than we usually expect of it. But that's in its unusual mode. It's not a G5RV, it's in fact a Marconi T. Now that I don't think he misses on any bands whatsoever. I think he can make a match on all the HF bands. but he'll have to put me right on that one later on. Right, now there's a picture. That's the whole thing is supported on a 4x4 tannalized fence post set in the ground. It goes in the ground about 3 feet, as deep as could be dug by hand by reaching down the hole, and kept as small as possible. And then postcrete put in round it. And I don't know if you've not ever used postcrete, but if you want an instant aerial, it goes off. It goes off literally
It's incredible.
in 10 minutes.
Yeah, it's unbelievable.
You've got to be quick. You've got to make sure it's upright. Otherwise, you'll be digging it out the ground.
Yeah.
But that's the actual support. If we go on to the next picture, you can see where you're actually looking. It's taken at a funny angle, this, but the black pole is vertical, really. So really should swivel it round. The box contains the ASMU, and the feeder to the antenna comes down out the bottom of the tube and back up to the ASMU. Next picture, what's the next one we've got on that? Oh, that's just the other side showing the lashing. Again, just using rope to lash it on. Quick, easy, relatively easy to undo. In fact, we have rubber bungees on it first. You notice the spider beam pole. Can we go back one?
Of course.
You notice, if you look at the black spider beam pole, you'll see 2 bits of timber either side. They are just 1 inch square pieces of timber, or 1¼ inch square pieces of timber screwed to locate the pole in a vertical position. Makes it much easier to put it up. And at the bottom, which you can't see, but just behind the white box, there is a little pedestal for the pole to stick on, so the feeder can come out from underneath it. Okay, forward. Next one. Now this is a typical toolbox, which is very, very useful when you're actually working out on the field and doing areas. This is really for the beginners. But a caddy, which I've got all the various things I might need, screwdrivers and that, etc. Now, this flux I use is this Everflux. It's extremely good. It's an acid flux. So it's worthwhile having a small bucket of water and a towel handy, because if you leave it on your fingers too long, they do start to sting a little bit. So it's handy to just be able to dip your hand in the water, having then you can handle the flux, put it onto the stuff by hand, and then clean yourself up. On the top right hand picture, you'll see at the end of a wire and how I actually do the cable, do the ends of the wires. They're multi-strand wires. They're in fact the 2.5mm speaker wire or power wire that's used on the back of rigs, which I use as a 100 ohm feeder normally, but I've taken my 100 ohm feeder and split it down the middle, and I've made a ladder line to go up on my aerial. Now at the end of where you strip the insulation off, you can see in that top right picture, you see a spiral. What I do is I dip the wire into the flux, so there's good wire flux embedded in the wire. Then I wrap solder around the wire to hold it all nice and together while I'm working. Then, whereas I used to get the big soldering bolt out and extension lead and have to get all that out and then put it all back afterwards, I've now gone back to the old soldering bolt, and it's a delight. You just put your gas torch, which you can see in the bottom left picture, a nice ignition gas torch. Best £60 I've ever spent. It's always by my side in the workshop.
Oh.
Working on the cars.
Now, then?
What?
You didn't bring it tonight? Then?
No. I left it home. I didn't think you'd want me to making smells in the house. But the soldering bolt heats up within a minute with the gas torch. You plonk the wire on using a bit of solder at the same time to make conduction, and zoom, you're soldered. It's done. So it's a far better way than trying to use a standard soldering iron out in the weather. Right, so now this is a one for you chaps out there that perhaps you can help me. This is an ASMU, which is a pi network. I've worked out it's a pi network. And I would love to know what piece of equipment it's from. If you happen to recognize it, can you please let me know? Because I would love to know. There's numbers on the board, but nothing that Google can't find anything about it. By the way, the relays on the right are those white things on the right. They 3.5 kV at 6 amps. They can switch. They're vacuum relays. They're 130 pounds each. So when I saw the board up for sale for 45 pounds, I thought that was a good investment. In fact, I use those relays in my big valve linear, and they're excellent relays. So that's it. I think we'll throw the floor open now to anyone that wants to ask us any questions. No one.
They all need to unmute themselves first, Ian. But so having various aerials over the past 5 years, I actually am currently using a hex beam, which I'm having the most fantastic results. And it just goes to show that if you improve your aerial systems as you go along, it's amazing at how far I can DX now with ease, as opposed to when I first started off and you came round and we did the long wire. It's quite amazing how many stations are actually present and you just don't hear them because the aerial is just not adequate enough.
Yeah. That's something that's also very important, if at all possible. Have an external receiving aerial. I have a system called the Sal 30 up at the moment, which I'm playing with, and I tend to use that a lot. But the hex beam, I would agree, it's wonderful. The only time I've ever done anything with a similar to a hex beam was, I can't think of the name of it now, but it was based on just 4 poles from the center pole. We did it on 20 meters, 2 elements on 20 meters, and it was evil. It really was, and it was so light. But that was a single bander. We tried to put some other bands in, but we couldn't make it work, so we gave up. But the hex beam seems to have cracked it. It's a good antenna, very good antenna.
Yeah, I like using it. I know that Peter G3ROO, he's got one as well, and he's having some good results. It was quite interesting because I'd gone from a dipole, for example, say a 20-meter dipole, and I'd gone from that to a hex beam, and straight away I got into Australia and New Zealand and Japan, all on SSB, and it was a bit mind blowing really at how the improvement was just great.
Yeah. I'm looking. I think we're going to have a good peak this time. I mean, the bands are in quite good condition. I use reverse beacon network quite a lot, which of course you can only use on CW.
Yes. Yeah.
But my goodness, the conditions are there. The other day on 40 meters in the middle of the afternoon, and I got 4 returns from VK in the middle of the afternoon on 40 meters.
Wow.
I just couldn't explain it. Can you explain it, Peter?
No, I mean, at the moment, it's quite amazing what is going on the bands, because regularly I speak to John in Perth on 20 meters in the morning. And it's always 5 and 9. He always gives me 5 and 9. And this morning, as I was saying earlier, there's absolutely no long path propagation at all. The Europeans further east and down on the Mediterranean were hearing VKs, but I was just hearing the lightest signals, wouldn't be able to read a call sign. And that was very unusual, but I gather there's been quite a bit of activity on the sun. But there has been a lot of activity on the sun, but it hadn't affected it in quite the way it did this morning. So the bands are, as you say, coming good. I haven't been doing much on the low bands lately, but I am now building more wire antennas. I had the hex beam up. I like that very much, and but I tell you that the hex beam we're replacing a monoband, a 4-element monoband that I've built and had up for many years on 20. And I really don't notice the difference. Now, okay, the bands are getting better, but the I think the hex beam, they say now the hex beam and the 7300 seems the standard bit of kit to use. There's so many people are using that equipment. But, you know, antennas all, but like you now, I've always enjoyed playing with antennas because they're cheap and easy to build yourself. And over the years, I had some successes and some bad experiences. But I would advise anybody, you learn so much about propagation, and you know, you get the great sense of achievement when you get an antenna working that really works for you. So don't ignore antennas. This is coming from an 83-year-old, been in the hobby for nearly 65 years. So, you know, I would urge anybody to actually experiment with antennas. You'll enjoy yourself.
Yeah, okay. Yes, Peter. I'm sorry. I didn't bring my hearing aids with me, and I'm having a bit of trouble hearing. Silly of me, but
I'll catch you up.
yeah. Come on. Yeah, just one thing. Seeing Nigel sitting there talking about conditions. One morning last autumn, we were on top band doing the Morse practice, the Morse sending, and I got an email from VY3ZN, can't think of his name, Jeff, to say, I can hear you. This was 10 o'clock in the morning here. It was daylight with him, and we had a 599 CW QSO both ways, 599. What's happened to top band? What's happened to the D layer? Astounding, absolutely astounding. Can't understand how we managed to get that part. Must have been over the pole, of course, but but anyway, well, that's just the bands. They're not behaving as we expect them to behave, are they?
Oh no, definitely not. I mean, they often say, you know, people tune around and you know, if you look at 17 meters, often that band appears to be dead. But you put out a call, you get somebody come back.
Yeah.
So, you know, never ever assume that the band is dead because you're not hearing anything.
I wonder if climate change has changed things.
Yeah, but how?
I don't know. You're the expert.
I'm not. Oh, that's one thing. Propagation is still a mystery for me. I just try to hook into it.
It's magical.
Yeah.
Well, guys, I'm sorry, but I'll have to leave you. But it's been very, very interesting. I don't understand a lot about antennas. I was off radio for about 8 to 9 years, and I've forgotten more than I know now. I still teach CW though. I love CW.
Well,
I love to encourage people on the bands. In fact, I've got one guy's going on in the morning. He's not been on the CW band yet. He's going on 2 meters in the morning. I don't know if he knows it or not, but he's going.
Yeah,
so there you go.
Keep up the good work there. The ultimate digital mode, I say.
Absolutely, yeah. I'm not into this FT8 stuff and FT4 and no. I like to talk. Yeah. Right, thanks guys. It's been lovely meeting you all. I'm in Bury, by the way. Well, no, actually I'm in Bolton, but I'm the chair of Bury Radio Society this year for my sins. They said, do you want to be the chair lady? And I said, no, because you'll take the eye out of it. and then I'll be the chair lady. So I'll just be the chair. Thank you very much.
Oh, lovely. Nice to meet you.
Okay. I look forward to the next one. If you're doing on CW, I shall be around. Okay, guys.
Bye.
Three, everybody. Bye-bye for now.
Cheers,
Bye-bye.
Linda. Good
Bye,
night.
everybody. Bye.
What
a lot.
So Aaron has put a comment in the chat, Ian. So he's put, I'm currently using a 3D printer and he's creating parts for a collinear folded dipole phased array for VHF 2 meters. And he's also doing one for RX on 137 megs. Have you any experience of phased array?
I have phased arrays in the past, but I'm at a loss to what he's actually asking.
Well,
Well,
you, Aaron.
Okay.
yeah. Am I on? Yeah, I am.
Yeah, you are,
Yeah.
mate. Yeah.
Well, basically, Ian, I've not got a lot of information as to. I like the idea, but I've not got any information or a lot of information regarding somebody who's actually used them before and how good they are or how bad they are. I mean, my reasons behind it are purely for space. I've not got a lot of space, so with a collinear in phased array.
This is for VHF.
Yeah.
Well, in fact, phasing on VHF is considerably easier than it is on HF because it's all manageable sizes.
Yeah.
Whereas we're talking about phasing lines, quarter wave phasing lines, 10 meters long, and you've got to sort of. But basically, your beam, your standard 5-element Yagi is a phased array. But you're thinking about it at the verticals, are you?
Yeah.
So you'd have two collinears. Well, basically, yes, you just put a phasing line between the two. Have you ever tried one of these programs like ESNEC and MMANA?
I haven't. No, I must admit, I haven't tried it.
You can put that. You can draw the aerial into that, and then you can do the phasing by. Basically, what you actually have is you put a wire on the screen, and you tell it where you're going to feed it. You're going to feed it at the bottom, and then you tell the next aerial. You put the next aerial the distance apart you want, and then you can then tell that aerial that you're going to feed it 45 degrees out of phase to the other one. And then you can do a polar plot and it will draw those field patterns so you can see what's actually happening. And then you can alter the angle. Once you've actually found the optimum angle to get the beam heading you want, the type of beam you want, you can then use just a little bit of maths to work out how long the feeder has got to be to give that time delay.
Right. So have you actually built one in VHF for VHF?
Not on VHF, no. I'm actually building a phased array for 40 meters at the moment. It's another one.
Right, okay, yeah.
And that's on one of the towers, and that's their dipoles. And
that's the sort of idea I'm going along is folded dipole collinear.
Yeah, that's right. So
with obviously using 4 elements. I just wanted an idea of
going above. Once you start going above 2 elements, it gets very confusing.
Right. Okay.
You can use to advantage passive elements. So you would have a couple of driven elements, and that will give you a clover leaf. Not a clover leaf. What's a cardioid pattern?
Cardioid, yeah.
So that'll give you a cardioid pattern. Then you can put parasitic verticals at various points and just literally stick them on as if they're sort of aerials, but no driven. no drive.
Right. Okay. Yeah.
And alter the pattern by positioning those. So you can make an array. That's exactly what you do in a 5-element Yagi.
Right. Right.
If
That
I
sounds
was-
interesting. Yeah.
Yeah. However, if I was actually wanting to make a phased array, I would be still tempted to use a beam on its side. If you
Right,
want
okay.
polarization, because it's easier to make a beam with parasitic elements than it is to mess around with phasing lines, which not really going to give you much in the advantage.
Right. So you think a Yagi would be the way to go? Do you think?
Well, yes, and a vast Yagi in the vertical plane rather than the horizontal. Well, Peter, MLO,
Yeah.
you
Yeah.
have more experience on this than me.
Yeah, well, I've got 4 10-element Yagis that are horizontally polarized, and that's what the 2-meter EME station, they were built for that. But that uses a power divider. So
Right,
the 4
okay.
Yagis, you've got a half wavelength. It's like a bit of waveguide, really. It's 50 ohm anyway, and you take the 4 Yagis off of each end of the bit of waveguide, and you feed your transmitter into the center. So I don't see why that wouldn't work.
Yes.
You know, that sort of, the information is out there. If you look up, you know, VHF book, if you haven't got one, I've got the stuff here, and you know, you can do 2 elements or 2 Yagis, or you know, 4. That gives you obviously the extra gain. So it depends what you want to do. If you're looking, obviously,
It's just a project that I fancy, to be honest, Peter. It's something that I've looked at, and I can build most of it on a 3D printer sort of thing. So
yeah.
I just thought it's a project. You know, I'm doing a helicoidal antenna at the moment as well.
Oh yeah, that's good.
Purely on the receive side, that's going to be for the receive. It's not going to be for transmit, but that's quite challenging.
Yeah,
but yeah, I'm getting there. Yeah.
Well, if you want to borrow some books, I got a lot on VHF. You know.
Okay.
Antennas. Yeah.
Okay.
The 4-way splitter is a good idea, because you could actually use different feeder lengths to each of the arrays to give you the time delay that you're looking for.
Right.
Yeah, well, on the 4 antennas, they're all equal lengths of feeder.
Yes.
So, but you can play around with all sorts of things, I guess.
Yeah, but that's for a turnstile, isn't it? To basically to give omnidirectional work, we gauge.
Yeah.
Whereas if you phase them by all lengths, you could actually make a polar diagram.
Yeah.
You know, a cardioid.
That's right. Yeah.
Okay. I've got some interesting pointers there. That nice one. Thank you very much.
Yeah.
I've got a question for you, Ian, or anyone else there that can that's at Dover Club. I would like one evening somebody to actually sit down at the club, at Dover Club, and explain how the modeling software works, because it's one of those things that looks absolutely great and will give you a lot of visual feedback to how an aerial is performing, but you have to understand how what it's actually showing you. Does that make sense?
Yeah, I'll say something. So we have kind of played with these applications before, but unfortunately we only had a really rubbish projector. Emily and I have bought a really nice projector, and everybody will be able to see it. And I agree. I think we should do it again.
Yeah. Well, anyone done any work with MMANA?
No, I haven't. I haven't. I've looked at. I will be honest. I've looked at it, and I thought wow, this is great. And I've looked here and then I thought, oh, I don't know what I'm doing. So I just, you know, left it alone. But I would love to be able to use it for you know, for looking to just see how my current aerial is performing. But more, you know, it's like when you get an idea and you think, I wonder whether that's going to actually work. It would be nice to plot something to see if it's going to work rather than spending the morning having a go and then finding actually this is not going to work at all. But
it will definitely tell you whether it's going to work or not. You know, you can.
Yeah.
That's a nice thing.
Right. Cool.
Discrepancies, as I pointed out in one of those polar diagrams, the game figures were ridiculous, and I couldn't find out why. The drawings, the actual plots looked sensible, what I expected, but the game was 8 dB. That wasn't so.
Well, if we could do an evening, I would really appreciate that, just so that I you know, understand how you use the software and read the information that it offers. I would appreciate that. And then I've got one other question. So I've got one other question for the evening, and the question is, what would you recommend? So we have, hold on, let me take, that's better. So what would you recommend? I'm here. So what would you recommend? A lot of people nowadays, a lot of amateurs have got gardens the size of a postage stamp. And I find that a lot of them will always venture towards 2 meters, 70 cms, more localized, because it's something that they can throw on a chimney stack or, you know, kind of fix the building, and they're up and running. Not so much with HF, because they've got such small gardens. What would you recommend for an M7 or an M6 that's just come into the hobby, who may be watching this video on YouTube at a later date? What would you recommend them for a very simple aerial in a very small garden? Because on the housing estates, etc., people have just got gardens that are absolutely nothing in size.
I've got one. 10-meter fishing pole, not a spider beam pole, 10-meter fishing pole with a wire down the center, strapped to a fence post. As you can see how you don't have to do massive engineering projects from my pictures. Strapped to a post, an AH4 at the bottom with the coax back to the shack, and you'll work 40 meters up, no problem at all. You'll more than likely be able to put up a reasonable signal on 80, maybe even 160, you never know. But, you know,
and an earth.
Oh, yeah, yes, and the earth. The earth is the important thing, because you've got to get that power back to the shack. But, you know, even the earth, just the one earth spike is going to tell you whether it's going to work or not. It's only going to get better when you increase the number of earth rods. Well, you know, on your earth, when you did your earth, that was just round the garden. Made a big difference.
You're on mute, Andy.
Sorry. Yeah,
that'd be quite embarrassing, wouldn't it?
Yeah. No, it's a huge. It made a huge difference when I put the earth around. You're absolutely right. Yes. Yeah.
And of course, you don't. It's just self-supporting. It won't.
Yeah.
It won't blow over.
No.
The worst can happen is a lightweight fishing pole is going to break, but
Yeah,
that's all that's going to happen.
Can I ask a question regarding wire antennas? I've read a lot of articles where they say they don't recommend the radial or the well, I don't even know if you can call it a ground or anything like that, but they don't recommend anyway the earth touches the floor. They recommend you keep it at least 5 inches off the ground.
This is for resonant radials.
Yeah.
Right.
We've gone away over the last 5 years. We've basically said that the resonant radial is not really worth all the effort. You need 60 of them to really make a really good earth.
Right.
We've just found that, in fact, actually laying the wires on the ground, bare copper wire on the ground, is as good as
That's your
anything.
best bet.
Well, like my roof. My roof is the ultimate, isn't it? It's a million wires, 25 feet from the aerial point. You know, by the diminishing returns is whenever if you put down 50 wires, you'll get a dramatic effect over the single earth rod. If you put down 150, it won't be a great deal of improvement. So it's diminishing returns all the time. So anything you can get down close in is worth it. Around the perimeter of the garden is one where you don't actually impinge upon the living space. But of course, if you can run wires across in the turf across the garden, there's going to be an improvement. But because you're screening off more of that soil and getting the energy back by the lowest impedance route, and that's the wires.
Pizza wheel's a good way of.
Oh yes, yes, could do. Who's that? Who's that phone? The one mark.
All right.
It was that gentleman.
Yeah, I think for the single to go back to you, Andy, there the fishing rod, because it's so light, a single wire up the middle of it, cheap, yeah, 25 quid for, I don't know what they are now. There's 25, 30 quid maybe. A bit of wire that you get at the local boot fair, and an AH4. I'm sorry to go on about the AH4, but it's by far the best matching unit that I've used. And I was reading a report by an American earlier on today about the AH4, and he agrees. It's way above the spec is way above what they actually claim. They say it's 80 to 10 meters, but it does a super job on 160, and it's got a very wide matching range as well. What was that? Flashes.
It's probably a fire engine or something.
Oh, right.
That's 100 watt, isn't it? The AH4. Is it 100 watt?
It's 120 watts.
Right.
This gets me onto a little bit of a pet hate at the moment. I mean, I'm a confirmed Icon man, not just because they're very nice pieces of kit, and also they're just up the road if you do get a problem. But I use a 7851. When I started playing with the area, I thought, oh well, I'll just use an AH4. Went to plug in the AH4 on the back, and they've done away with the Monex plug on the 7851.
Oh gosh.
Very annoying, very annoying. But the reason they've done it is because it's a 200 watt rig. The AH4 is only rated at 120 watts. But I've been running the AH4 with the 200 watt rig, and no trouble so far. But of course, I don't recommend you do it unless you do it at your own risk. But the real gem of the AH4 also, which they don't advertise, the fact that it does its tuning at 350 milliwatts. So the relays are no strain on them at all. There's no arcing at all as it does that rapid switching.
Right.
So that's one thing that really, that's what fails in matching units, are the relays. And well, I can't see why they should fail. The disadvantage with the AH4, it does not use latching relays. It uses standard relays, so that if the power's turned off, it's got to do a tune. But it does the tune in 2 seconds.
Right. Oh, okay.
So very fast, because they don't have to worry about switching rates. Very fast. And if you want, you can turn on PTT tune. So what happens is that whenever you press the PTT button, the tuner tunes. Or checks that it needs to tune. So if the air has been waving around or fallen down, it does the tune.
The other good thing about tuning on such low power is you're not interfering with other people.
Yeah, that's right. Yeah. Very
What can I ask? What would you what do you class, Ian, as a good matching range for an AMU?
I would like to see down to somewhere in the region of 10 ohms, in the lower region. And really, in VSWR, 10 to 1. And I think I'm sure that the AH4 can handle 10 to 1. I've never checked what it will handle, but
okay.
But we want down to 6 ohms. Of course, you can hope the tuner by using a balun on the output, a 4-to-1 balun, which means, of course, you can go to higher. You're converting the higher impedance down to by a factor of 4 for the AH4 to handle. So in my matching unit, where the photo where you could see the base of the spider beam pole coming through the roof, there's a balun there, which is a 1-to-1 at the moment. But in fact, I might get more tuning range if I went down to a 4-to-1 balun. And the interesting thing was that I was very concerned about using baluns in situations where we've got very high impedances, because the voltages, of course, are going to be stepped up proportionally.
Yeah.
So I thought, well, there's only one way to do it, and that's to try. And so I wired the first one up, and I used standard hookup wire on the balun. And first thing that happened was it flashed through, the voltage flashed through the insulation. So I made my own insulated wire by using 22 gauge, bit thin, because I only had 22 gauge, and I put heat shrink sleeving over it, fine heat shrink, 1 mil heat shrink sleeving over it, and wound the balun then. And then I didn't get the flashover problems. And I thought, now what's going to be the problem having such high impedances on the balun? So what I did, I turned the thing on to 100 watts, left it there for 10 minutes, and went down and touched the balun. That was on one band. Balun was still cold. And I did it on each band. And on no band did I notice any serious heating. 1 or 2 bands, you could feel the core had started to warm, but there was no serious heating whatsoever. So I was quite pleased about that, really. Because that would be one criticism I would, if I'd looked at my design, I would say, what about that balun? The impedance range of trying to use it over is pretty high, but it worked out in practice. Anyway, sorry, I've gone back into lecture mode.
That's all right. Right, guys, I'm just going to stop the recording while we continue, just to make it a little bit easier for John when he's actually you know, doing the editing. So if I stop the recording and then we'll crack on. But thanks very much, Ian, and cheers, Jonathan, for
yeah, thanks,
allowing us
Jonathan.
to have
Couldn't have done it without you, mate.
your work. Yeah, exactly. We couldn't have had the evening without you. It's very much appreciated. Cheers, Jonathan.
Pleasure.